Let's continue with our arithmetic or algebra functions. I'm going to again let my f of x be my orange function. We have 2 minus 6x all over x plus 7. I'm going to let g of x be my purple function. So x squared plus x plus 2 all over x plus 7. Since we're working with rational functions starting out, let's go ahead and find our restricted values of both f and g. So if we find the restricted value for f, take the denominator equal to 0, we find out that x cannot be negative 7. We take g of x denominator, and again, we get to the same number because we have the same denominator. So we find the restriction that x cannot be negative 7. Now that we've found the restrictions, let's go ahead and find whatever algebra or arithmetic they're asking us to find. So if we have f minus g of x, that means that we are going to take our f of x minus g of x. Okay. Let's plug in for our functions. So I'm going to have 2 minus 6x all over x plus 7 minus x squared plus x plus 2 all over x minus 7. Okay. Whenever you add or subtract fractions, you have to have common denominators. We got lucky. They already have common denominators, the x plus 7, which means that we can combine these by adding or subtracting the numerators respectively. So I'm going to have 2 minus 6x, my f function. I'm putting parentheses around the numerators because we have multiple terms, so I'm going to make sure that I'm combining them properly. So in my g function, when I am subtracting these 3 terms, I want the parentheses because I'm going to have to distribute that negative all the way through. When you add your fractions, think back to just regular fractions that aren't hopped up on steroids and don't look like they want to hurt us, like these rational functions. Okay? If you had 1/4 plus 2/4, we got 3/4. We didn't get 3/16, we didn't get 3/8, we got 3/4. So when we add here, our denominator is not going to change. It's going to stay x plus 7. Except now we have all of it in one fraction instead of 2. In my 2 minus 6x, which is at the front, there's no number out front to distribute. There's no negative to distribute. So I'm going to drop my parentheses, 2 minus 6x. But in the G, in the purple, we need to distribute that negative all the way through all 3 terms. So instead of instead of a positive x squared, we have a negative x squared. Minus x minus 2. If any of these were negative, they would become positive. So for instance, if I had a minus 7, it would become plus 7. All over my x plus 7. We're going to combine like terms. I'm going to start with our highest degree with the leading coefficient. So negative x squared. My 2's are going to cancel because I have a positive 2 and a negative 2. So I only need to look at my negative 6x and negative x. which get me negative 7x all over my x plus 7. You may be wondering why I haven't stopped to find any new restricted values. It's because our denominator hasn't changed. But we're not done yet in this problem, because whenever you think you're done, you need to make sure that nothing can be simplified. And right now we can't cancel anything out because the 7s can't cancel because one of them has an x, the other one doesn't. But we have an x squared happening up top, which means we kind of got to look, see if it'll factor. I know you're over it already, but we got to do it. Notice that up top, they have a GCF of negative x, which means if I factor out a negative x, I take out the negative of the x squared, I take out one of the x's, so I have an x. I take my negative away from the 7x, it becomes plus 7 because I took the x out. If you don't understand what I'm saying, I'm doing this step to factor out the GCF. And that's how I'm getting to the negative x times x plus 7 all over my denominator of x plus 7. And notice both the top and bottom, I can get rid of the x plus 7, which gets us to negative x. We just found that f minus g of x is equal to negative x. Notice if we hadn't found the restricted values at the beginning and we tried to wait until the end, you would tell me that there were no restricted values because we wound up with a polynomial. But that's not the case because we started with two functions that had restrictions. So we have to keep those when we're looking at our domain. So let's go back up. We had a restricted value of negative 7. It just showed up twice. We don't have to write it twice. But we need to use it in our domain of f minus g. So go ahead and draw your little number line. The only thing on that list is negative 7. And we can't be negative 7. So our domain is going to be negative infinity to negative 7, close parenthesis. The jump rope, the union, because we got to jump over the negative 7, and then negative 7 to infinity. And that is our domain of f minus g. Let's look at another one. This time we have two rational functions. And we need to find g divided by f. So again, I'm going to let f of x be my orange function. And I'm going to let g of x be my purple function. And since I have these fractions, let's go ahead and find the restricted values of f and g before we begin. So we would take our denominator, set it equal to 0, and solve. If you want, we can use the square root property, or we can factor. If you do the square root property, you would have x squared is equal to 9, which means that the square root of x squared is equal to plus or minus square root of 9. And we have x is plus or minus 3 for our restricted values. If you want to factor, this becomes x plus 3, x minus 3, because you would be looking for a product of -9 and a sum of 0. We find out that x cannot be -3 and x cannot be 3. So either way, we get to the same restrictions. So back to where we were, we need to find g divided by f of x. This means that I'm going to take g of x, I'm going to divide it by my f function, 5x plus 1 all over x squared. Oh, I skipped a step. Let's try that again. Getting ahead of the game. Way ahead of the game now. Technical issues. All right, so here we go. F of x, taking it back a step. Okay, now I'm going to plug in for what we have. So instead of g of x, I'm going to actually write out 4x minus 2 all over x squared minus 9. And then my f function, we have 5x plus 1 all over x squared minus 9. This means that we are taking our g function divided by our f function. And remember, whenever you divide by a fraction, we're going to multiply by the reciprocal. So this means that we have 4x minus 2 all over x squared minus 9 times x squared minus 9 all over 5x plus 1. And new denominator means that we need to stop and find the new restriction. So we're going to take 5x plus 1 equal to 0. 5x is equal to -1, and we find out that x cannot be -1/5. As soon as you get a new denominator, you need to find that new restriction. Our next step is to factor everything to see if anything can cancel. In our first numerator, there's not an x squared, so we don't need to do bottoms up, but there is a GCF. So I'm going to factor out my 2 and have 2x minus 1 left inside. The first denominator we factored when we were finding the original restrictions. It's x plus 3 times x minus 3. So that's the same for our second numerator. And that is all over the 5x plus 1. And now we can get rid of anything that shows in both a numerator and a denominator. So both a top and a bottom. The x plus 3 shows up in the bottom of the first fraction and top of the second. Same thing with the x minus 3. Which means the x minus 3's are gone. There's nothing else that'll cancel. The ones aren't going to cancel because the one in the first numerator is with the 2x, and the one in the second denominator is with the 5. So we wind up getting 2 times 2x minus 1 all over 5x plus 1. And that is our answer for g divided by f of x. We still need to find the domain. I'm going to do this over on the left where I have some space. We have 3 different restrictions this time. I'm going to be squeezing this into one little number line. Negative infinity on the left, positive infinity on the right. -3 is the most negative, so it goes first on the number line. Then I have -1/5, and then a +3. Because we have 3 restricted values, we are going to have 4 parts to our domain. Remember, it's always one more. So we have negative infinity to -3, union -3 to -1/5, union -1/5 to 3. We were just right here. And now we are at 3 to infinity. Remember that each time that you need to skip over a number, you're going to need the jump rope, which is the union. So we just found our domain of g divided by f of x.